Hello, this is going to be lesson A1, the greatest common factor and factoring by grouping. On example 1, I'm asked to find the greatest common factor that goes into the greatest common factor of these three monomials, okay, or these three terms, okay. So basically, greatest common factor is I'm looking for the biggest number that I can factor out, that I can take out from each one of these terms. So how do we do that? Ask yourself, what is the biggest number that goes into 12, 16, and 24? Well, the answer then would be 4. Because 4 goes into 12 3 times, 4 goes into 16 4 times, 4 goes into 24 6 times. Now, when it comes to the letters, okay, we want to make sure to factor out the same amount from each one of those terms. Okay, so this guy here has 1x because if a number does not have an exponent, that means the exponent is invisible 1. This one has 3 x's and this one has 2. Okay, so if I try to factor out 2 x's, I will be able to factor out 2 from this guy. From this guy's I will be able to factor out, but this guy won't. So to be able to find out the greatest common factor, basically what you're going to do is look for the smallest exponent. Well, the smallest exponent here will be x to the first. So that tells me that I can factor out just 1x. Okay? Alright, let's look at the y's. Can I factor out a y? Does the y occur in each term? And the answer is no. So that means I cannot factor a y. So in other words, the greatest common factor of all these three terms is 4x. Let's look at another example. What is the biggest number that goes into 12, 48, and 15? Well, the biggest number would be 3. Will I be able to factor out a y? Does the y happens to all three terms? And the answer is yes. What is the biggest amount, what is the biggest amount of y's I can factor out? Okay, from all three of them. Well, look for the smallest exponent, and the smallest exponent would be y to the second. How about the z? Can I factor out a z? And yes, z occurs to all of them. And what is the smallest exponent? Z to the third. So that's how you find the greatest common factor. Alright, so let's look now into factoring. Suppose I'm asked to factor these binomials. Okay, these here are called monomials because it has one term. These are called binomials because it has two terms. Okay, letter D, for example, here is a trinomial because it has three terms. So let's see, how do I factor this guy? Ask yourself, what is the biggest number goes into 49 and 35? And the answer is 7. Can I factor out an x? Well, x does not occur to both of them, so I cannot factor out an x. Okay, so the only thing I can factor is a 7. Once you decided what you can factor, go ahead and open parentheses. And now start dividing. 49x divided by 7 is 7x. Negative 35 divided by 7 is negative 5. And so we're able to factor a 7 out of this binomial. And notice you can double check if you got it right by multiplying back the number into the parentheses. For example, 7 times 7, x equals 49x. 7 times negative 5 gives me negative 35. That's a confirmation that I did it correctly. Alright, let's look at letter B. Can I factor something out of 5 and 2 other than 1? Because 1, we don't care. Okay, it has to be a number other than 1. So in this case, there's no number that goes into 5 and 2. Can I factor out an x? No, I can't. So in this case, we call it prime because it cannot be factored. Okay? Alright? And yes, you can factor out a 1, but the 1 is considered prime. Okay? Alright. Letter C. What can I factor from these two terms? Well, they both have z's. And what is the smallest exponent? The smallest exponent is x squared. So that means we can factor out a z squared. And what we do is, now we divide. Z to the third divided by z to the second gives you z to the first. Z squared divided by z squared is 1, so negative 1. Okay, and that's our factorization there. Now we have a trinomial. What is the biggest number that I can factor from 3, 15, and 9? Or what's the biggest number that goes into 3, 15, and 9? And the answer is 3. Can I factor out an x? Yes, I can, because x occurred to all of them. How many x's can I factor? Look for the smallest exponent. The smallest exponent is 2, so I can factor out 3x squared. Once you decided what you're going to factor, open parentheses, and now let's do the division. 3x to the 4th divided by 3x squared. 3 divided by 3 gives you 1. X to the 4th divided by x squared gives you x squared. Negative 15 x cubed divided by 3x squared. Negative 15 divided by 3 is negative 5. X cubed divided by x squared is x. Because 3 minus 2 gives you an invisible 1 there. And then the last one is positive 9 divided by 3 is 3. And x squared divided by x squared, the x squared cancels, so I'm only left with 3. And that's my factorization there. Let's continue on. Here's letter E. What is the biggest number that goes into 12, 10, and 2? The answer is 2. And also, can I factor out a b? Yes, I can. How many b's can I factor? Well, the smallest exponent would be this invisible 1. So it would be 2b. That's what I can factor. Now, we usually like to not have a negative here in the front. So to avoid having a negative here when we open the parentheses, I'm going to go ahead and also factor a negative. By doing that, I'm going to force that this first term over here be a positive number. So let's see how it goes. Negative 12 b cubed divided by negative 2b. Negative 12 divided by negative 2 is positive 6. B cubed divided by b to the first. 3 minus the invisible 1 is b squared. Alright. 10b squared divided by negative 2b. 10 divided by negative 2 is negative 5. And b squared divided by b is b. And then the last one is negative 2b divided by negative 2b will be positive 1. Okay? Alright, next one. What is the biggest number? It goes into 18, 9, and 27. The answer would be 9. Can I factor out an x from all three terms? Yes, I can. If I look at it, the smallest exponent is 1. In fact, all of them have exponent 1. How about the y? Can I factor out a y? Yes, I can. The smallest exponent would be a 3. Now that I decided what I'm going to factor, go ahead and open the parentheses and start the division. 18 divided by 9 is 2. The x would cancel. Y to the 5th divided by y to the 3rd is y squared. 9 divided by 9 gives you a 1. This would be positive 1. The x would cancel. Y to the 4th divided by y to the 3rd would be just y. And then the last one would be 27 divided by 9 is 3. The x cancels. The y to the 3rd would cancel. So I'm left with just the 3. Alright. The next example would be this one over here. Is there a number that goes into 8, 20, and 27? And the answer is no. I mean, any number other than 1, and the answer is no. How about the a? Can I factor an a? Yes, I can. I can factor 1a because the smallest exponent is 1. How about the b? Can I factor out a b? Yes, I can. I would factor out b to the 3rd. With that in mind, 8 divided by the invisible 1 is 8. A squared divided by a is a. B to the 4th divided by b to the 3rd is b. Next one, negative 20 divided by 1 is negative 20. A to the 3rd divided by a to the 1st is a to the 2nd. B to the 3rd divided by b to the 3rd, the b to the 3rd cancels. The next one would be 27 divided by 1 is 27. A divided by A, the A cancels. B to the third divided by B to the third, the B cancels. So I'm left with that. Okay, so this concludes example number 2 of our lesson. So let's go ahead and go to example number 3. Okay. And let me go back first to example number 2 and just talk about a little bit about terms. Okay, this problem here has 3 terms, and terms are separated by the positive sign, or it could also be separated by negative signs. So positive and negative signs separate one term from the next. So this one has 3 terms. Okay, this one has 3 terms. This one has 2 terms. Okay. So now when we do example number 3, I look at this, and this would be considered one term, and this would be considered another term. And if I look at these 2 terms, what do they have in common? Well, if you look at it, they have y minus 1 in common. So that means I'm going to factor out y minus 1 from each term. So I'm going to factor out y minus 1. And if I do that, what I'm going to be left with? Well, if I take out the y minus 1 here, I'm going to be left with x. And on the second term, if I factor out the y minus 1, I'm going to be left with negative 13. And that is my answer to my factorization. So using the same procedure, let's go on to letter B. What do they have in common? Well, they have in common 2m plus n. And when I factor these out, when I take out this 2m plus n, I'm left with 5m squared. And if I take out 2m plus n, it looks like I don't have anything, but remember, there's an invisible 1. If I take out that 2m plus n, that negative 1 there has to become visible. So in other words, I'm left with negative 1 if I take out the 2m plus n. So this is my factorization for this problem. Okay? Alright, let's continue on to letter C. Letter C, I ask myself, is there a number or letter that I can factor from all 4 numbers? From all 4 terms? And the answer is no. There's nothing that I can factor from all 4. Okay, so then we're going to do something called grouping. We're going to group this in pairs. And I'm going to focus my attention on the first 2 at first. Can I factor anything from these 2 terms? And the answer is yes. They both have a, so I can factor out an a. So let's do that. So if I take out the a, ab divided by a, I'm left with b. And 4a divided by a is 4. Okay. Then there's a sign there, a positive sign, so let's bring that down. And what can I factor from 7, b, and 28? And the answer is I can factor out a 7. So if I do 7b divided by 7, I'll get b. And 28 divided by 7, I get 4. And would you look at that? I have 2 terms, and what do they have in common? They have b plus 4. So let's factor that out, b plus 4. And if I factor out b plus 4, what I'm left with? I'm left with a plus 7. So that would be my factorization. And this is a factorization by grouping, because I'm grouping the terms. Again, letter D. Can I factor anything from all 4 terms? And the answer is no. There's nothing that goes there into all 4 of them. So let's try by grouping. Let's group these first 2 and the last 2. What can I factor from the first 2? If I look, they both have y, so let's factor out a y. And if I factor out y, this becomes 2x plus 5, because 2xy divided by y, the y cancels, I'm left with 2x, and 5y squared divided by y squared minus, y squared divided by y to the first, 2 minus one, invisible 1, gives you, and I'm sorry, it's supposed to be 5y. Alright? Okay, Next one, I have a negative sign, so let's bring it down. What can I factor from 4x and 10y? Well, the biggest number that goes into 4 and 10 would be a 2. And I cannot factor out a letter. So that's the only thing I can factor, a negative 2. Negative 4x divided by negative 2 is 2x. And negative 10y divided by negative 2 gives you positive 5y. And would you look at that? I have two terms, and what do I have in common? 2x plus 5y. And if I take those out, what I'm left with, if I take the 2x plus 5 from here, I'm left with y. And from this one, I will be only left with negative 2. And that's my factorization. Alright, let's keep going to letter E. Is there any number or letter that can factor from all four terms? The answer is no. So let's look at the first two. What can I factor from the first two? I can factor out an x. And if I factor out an x, 3x squared divided by x is 3x. 4xy divided by x is 4y. Then I'm going to bring down the positive. Factor from these two. There's nothing I can factor, so I'm going to 1 there. 3x divided by 1 is 3x. And 4y
is 4y. Now I have two terms, 3x plus 4. And I remove the 3x plus 4y. What from the first term? I'm left only with x. And from the second term, if I remove the 3x 4y, I'm left with 1. And that's factorization. Let's try the next one. Can I factor anything from all four terms? The answer is no. So let's try by grouping. I'll draw a line over here to separate the two problems.
Okay, what can I factor from these two? Well, I can factor out an x, so let's factor out an x. 3xy divided by x is 3y. And x divided by x is 1. Put a negative down. What can I factor from 12y and 4? Well, I can factor out a 4. So I'm factoring out a negative 4 here. Negative 12y divided by negative 4 is 3y. And negative 4 divided by negative 4 is positive 1. Okay, what do these two terms have in common? 3y plus 1. And if I remove the 3y plus 1 from both terms, I'm left with x minus 4. And that's my factorization. Alright, very well. Let's go ahead and go to the next problems. Let's suppose I have these, and I ask myself, can I factor anything from all four? The answer is no. So let's try grouping. Can I factor anything from the first two? The answer is yes, I can factor out a 2. And if I factor out a 2, what I'm left with inside the parentheses? 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. Put a positive. What can I factor from these two terms? Well, I can factor out an x. Well, how many x's? Well, the smallest exponent is 2, so I can factor out 2 x's. With that decided, open parentheses, x cubed divided by x squared is x. And negative x squared divided by positive x squared is negative 1. Now, look at what they have in common. They have in common x minus 1. And that means if I remove the x minus 1, on the first term I'm left with 2. And on the second term I'm left with x squared. And that's my factorization for this problem. Alright. Alright, the next problem. Is there a number or letter that I can factor from all four terms? Well, on this particular problem, there is. 5 goes into all four terms. So let's go ahead and factor out of 5. 5xz divided by 5 gives us 3xz. 15yz divided by 5 gives us 3yz. Negative 5xy divided by 5 gives us negative xy. And negative 5y squared divided by 5 gives us negative y squared. Alright. We're going to keep this 5 on the outside, but we're going to try to factor this guy even more if we can. So let's try by grouping. Is there anything I can factor from the first two? And the answer is yes. So let's go ahead and write the 5 and put a bracket here, because we're going to do our factoring by grouping over here. So what can I factor? I can factor a 3 and also a z. And if I factor out a 3 to the z, a 3z, so 3xz divided by 3z is left with x. 3yz divided by 3z, I'm left with a y. Now I'm going to do the next two. There's a negative there, so bring it down. What can I factor from both of them? I can factor out a y. So negative xy divided by negative y is positive x. Negative y squared divided by negative y is positive y. Copy the 5. Now what do they have in common inside this bracket? They have in common x plus y. And if I remove the x plus y, what I'm left with on the first term? I'm left with 3z. And if I remove the x plus y on the second term, I'm left with negative y. So then this would be my prime factorization for letter H. Alright, last problem. Is there any number or letter that I can factor from all four of them? The answer is no. So let's group it. Is there anything I can factor from the first two? The answer is x squared. Not x squared, z squared. So if I divide by z squared, w squared, z squared divided by z squared is w squared. And 4z squared divided by z squared is positive 4. Bring down the negative. Now let's factor here. Is there any number or letter that goes into these two? The answer is yes. 8 goes into both. So negative 8 w squared divided by negative 8 would be w squared. And negative 32 divided by negative 8 gives us positive 4. And they have w squared plus 4 in common. So let's factor that. And if I factor out that, over here I'm going to be left with negative. And that factorization.
Alright, this concludes the example problems for lesson A1. So now, here are some practice problems in the book. So please go ahead and do all these problems. And then, so please go ahead and do all these problems. And then, do these problems 1 through 70, the odd numbers out of the book also. Okay? So thank you very much for your time and have a great day.